How dry will it get? And for how long? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 12th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, click the Stormsurf icon down in the lower right-hand corner of the screen. If you'd like to leave a comment or a question, do it down below. And of course, if you'd like to make a contribution, we'd really appreciate it. Hit the super thanks button down below, the heart with the $sign in it. And with that, I'd like to thank the folks that donated last week. Our Predicament, Evolution Moto, Tim Caston, our longtime contributors. Thank you guys so much. And then some other contributors that have been pretty recent lately, Clay Goose, Pierre Morton, and then a super contributor, Ben Brooks. Thank you so much. All your contributions are very generous and very much appreciated. And with that, let's get to work. We'll start by looking at significant wave heights for the entire planet. Starting in the North Pacific, we do have a gale with 36-foot seas, maybe 34 feet, pushing off to the east and generating swell. That, along with some other gales right before it, all heading towards the U.S. West Coast. Nothing huge, but rideable surf is forecast also down into the Hawaiian Islands. In the South Pacific, a rather calm pattern, as one would expect for this time of year. In the North Atlantic, we do have a gale with 40-foot seas, 42-foot seas, right down here, the highest seas over this entire domain with their coordinates right there. But all that energy is pushing off to the east, not aimed at the U.S. East Coast, and pretty good ways away from Europe still. Down in the South Atlantic, a quiet pattern. Then over in the Indian Ocean, a gale with 28-foot seas pushing off to the east, perhaps offering something down the road. But before we get into all that, let's take a look at current conditions. We'll start up in the Pacific Northwest, Grays Harbor buoy, number 036. That's off the Columbia River there. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period energy, 0.2 of a foot, down to 5 second period. This would just be pure wind chop. This would be super long energy swell. We definitely see a bump here in about in between 18 and 20 seconds with 3+ feet of energy in multiple bands. Pure swell is defined as the energy not just at one point, but both on the shoulders of either side of that peak. So looks like a bit of long period energy moving into the coast. We'll examine exactly where that came from and what it's going to do. And a bunch of wind swell and lesser period energy in the mix. Using some fancy math, primary swell, 4.8 feet at 19.1 seconds from 276 degrees. That theoretically is making surf in the 9-foot range, 9.2 feet. And then that wind swell, 4.9 feet at 10.4 seconds from 278 degrees, adding some 5-foot kind of bump and distraction onto the main event. Working our way south, we stop in Northern California using the Point Reyes buoy number 029, just north of the Golden Gate. Right there, again, we see the same profile, building swell at 22 seconds, and then a whole bunch of wind swell in the 9-second range. Primary swell, 9.2 feet at 10 seconds from 316 degrees, theoretically making surf at 9 feet, but the issue is really that north of an angle just doesn't get into San Francisco, and so you get about half that size. And then it's not even picking up the secondary swell. That is kind of interesting. I wonder why it didn't pick that up. But, you can guess this is probably about 2.5 feet at 22 seconds, something like that. Then we go down to Southern California, the Point Loma South buoy there off of San Diego, buoy number 191. Again, we don't see any of the long period energy. We see some filtered wind swell getting in and some limited actual semi-swell in the 13-14 second period range. Primary swell, 1.8 feet at 15.3 seconds from 274 degrees. That would make surf at 2.7 feet. We'll call it waist high, and yeah, that's about what it looked like earlier this morning. Then with some secondary swell mixed in at 2.1 feet, 11.5 seconds from 270 degrees. Now this swell, that's not its real angle. It's getting warped and pulled in by the Channel Islands, so it's probably much more of a north direction. Anyway, surf height from that again about 2.5 feet, we'll call it thigh high. Then we go to the north shore of the Hawaiian Islands, Waimea, buoy number 106, and we see a much quieter pattern there. The swell, the presumption is the swell that is hitting or poised to hit California was generated too far north and east of the Hawaiian Islands for any meaningful, even sideband swell to reach into the islands. I say that, but there was a little bit of bump of energy yesterday there, but nothing huge. Anyway, primary swell, 2.4 feet at 14.9 seconds from 324 degrees. That makes surf at 3.6 feet. And then some wind swell in the mix there, 3.1 feet at 10.3 seconds from 283 degrees. Again, waist high. There were waves head high, a little bit overhead this morning on the North Shore. So it's doing better than what the buoy would have one believe. All right, so let's go take a look at significant wave heights over the past week and sort of see if we can tease out what's going on. There was a gale that developed off the Kuril Islands falling southeast here on Sunday with 26-foot seas building to 28 feet. There we go, 31 feet right in there. And that continued into Monday. Yeah, another little gale zipped off up to the north associated with a front that was right along here, but no real swell for the U.S. West Coast resulted. This gale then eventually reorganized and redeveloped secondary energy on Wednesday off the U.S. West Coast with seas up into the 36-foot range, again lifting off to the northeast. There was a little bit of swell front, but I think there was a bunch of wind and stuff happening along the coast that basically rendered it unrideable for the most part. Now, also on Thursday, a gale developed over the North Dateline region with seas at 40 feet right there. Let's see if we can get even a higher reading, because I think there was one right there, 43 feet. Yep, 43.2 feet. Now, this is pretty far to the north, pushing off to the east. This is the storm that is making that 20-second period energy you see hitting the Pacific Northwest and starting to arrive in Northern California. Eventually, it'll slide into Southern California, but given this northerly position, it's going to be pretty shadowed from most breaks. Then after that, secondary energy developed from that gale on Friday night, the 10th of January, basically just piling more energy on top of pre-existing swell, while at the same time, another gale developed west of the dateline with 32-foot seas. It kind of petered out and then reorganized again with 37-foot seas. That was about it, 37-foot seas. And that, too, again, pretty north. Energy from this poised for the Hawaiian Islands, and eventually will reach into the U.S. West Coast later in the week, and then that was it. We'll go take a look, the same thing for the Southern Hemi, the South Pacific, but given the time of year, one would not expect anything of any meaning to really occur, and I don't think it has. There was this little gale off New Zealand here with like 26-foot seas for about 24 hours. I mean, that's good for swell for Tahiti. I'd be kind of surprised if anything meaningful shows up on the south shore of Oahu, but you never know. Anyway, and there we are. That was the end of that week. Blew through that pretty quick. The North Atlantic, again, the pattern is just consistently pushing from west to east following the jet stream. No big surprise. The jet stream pretty active. Really nothing aimed back at the U.S. East Coast in the past week. I think the forecast, there we go, and there's even one as of right now with 42-foot seas pushing off the northeast coast. But I think there is some hope in the future for like the southeast U.S. coast and even up into the northeast coast. So we'll take a look at that in just a minute. And then the South Atlantic, here we are. We're on Sunday, Monday. We're going to go through this pretty quick because I don't believe there is anything of any real interest that has occurred. But again, I think there is at least a little hope in the future if you believe the models. Now, the Indian Ocean, believe it or not, has actually done okay. Consider that we're, the peak of summer down there. Here we go. This little gale developed on Wednesday night, the 8th of January. That's like Pacific time. Seas 37 feet. Again, about 37, 39 feet on Thursday morning. and pushing off to the east. There's a little bit of 40-foot seas right there, but land right there is obscuring part of that. So, but I think enough energy will squeeze north of that to produce swell pushing into, we'll say, Bali, Mentawai Islands, Perth, and southern Australia or southwestern Australia. And then that system has faded out, and not a whole lot is starting behind that. So now we'll do a little bit of a deep dive for the North Pacific. We're going to start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet to the south. You sort of see one right there. You also sort of see something here, but that's over Japan, so not doing a whole lot. But the jet is consolidated with winds 170 to 180 knots, pushing off of Japan pretty much as it's been doing all winter, reaching to a point about north of Hawaii and then splitting. When you get a trough, what happens is you get a little counterclockwise eddy or counterclockwise circulation up in the upper atmosphere, and a lot of times that manifests itself down at the ocean surface. That is the hallmark of low pressure, and of course low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface and generate seas. Those raw seas eventually propagate away from the fetch area. The lesser period elements decay away, but the longer period elements hold on, they can survive, and eventually, as they move into your beach, that creates swell and that creates surf. So that's what we're looking for. Right now, we have a decent jet stream pattern, but not any real deep troughs as of yet. And the real issue, and what speaks to the title of this video, is all about this split jet stream here, because when you have a split jet, you get high pressure in between it. And specifically, you sort of see how it goes up here. That sets up high pressure up here in the north. It gives you like an offshore flow. Yes, it sort of looks like there's almost a backdoor trough coming down the U.S. West Coast, but it's dry as a bone. There's no precip in it. All the energy is getting wrung out over Alaska and nothing left to fall south. And this is a pattern we've been in for a couple weeks. My heart goes out to the folks in Southern California because things are just miserable, bone dry. Any precipitation would be a good thing, and we're not seeing a whole lot of it in the immediate forecast. But in that regards, we're going to try to tease out and see if there's even any hope at all not in the immediate future, because there really isn't. I'm sure you all have looked at all the local forecasts and everything. You look at the GFS model going out 2 weeks, and there's literally nothing. So we're going to go try to grasp a little bit further out, like starting the end of January into February. And I think, looking at everything, and you and I can go through this together, that there is some hope longer term. Right now, we're just stuck in a bad pattern, and there isn't any way out of it. All right, so let's go look for the immediate. Let's just go for the next week. As we get into Monday, a bit of a trough starts digging out here in the Gulf of Alaska, another trough off of Japan, supportive of gale development. Now, the trough in the Gulf kind of gets pinched off, doesn't do a whole lot by Tuesday, but this trough over here off of Japan has 180 knot winds feeding it. You can actually see the backwards circulation here, so that's a good thing, at least in terms of surf production. You see that it's literally an offshore flow building Tuesday, Wednesday. It looks like another offshore wind event, at least for North and Central California, and I'm hoping not for Southern California. Give the firefighters down there at least some chance to get ahead of everything. Anyway, on Wednesday, you see the jet here building to 190 knots, feeding that trough, pushing over the date line, again, supportive of gale development. When you have this just, again, horribly split, muddled pattern east of, we'll say, roughly Hawaii, really offering nothing there in terms of storm production. And there you go. That's as split of a jet as you're ever going to get pushing into the U.S. West Coast. Now, there does look like a bit of a trough up here into British Columbia, but we'll see if that really sags south. And not really. If it does, it's sagging south way inland. We're into Friday now, the 17th. At this point in time, Friday into Saturday, the 18th, we really don't even have any good troughs supportive of gale development. We have the big split pattern over the east. certainly looks like the inactive phase of the MJO at a bare minimum. We'll just roll this out to Sunday, and there we go, a week out. Now, there is supposed to be a bit of a trough here setting up over the, call it the date line roughly, probably the north date line. You see the jet still up here in Alaska, but you all see a lot of energy starting to collapse to the south, so maybe that'll give us a little bit of hope, but I'm not holding my breath. Let's move on. Now, for the past week or two, we've been talking about, one, the low pressure bias that's over the maritime continent. So there's South America, that's North America. This is the maritime continent there, New Guinea, Australia, all the Indonesian islands right in here, Japan up in this area. So this is the Pacific Basin. Notice the jet all split over Russia and India in that area, and not unusual. But then it all comes together somewhere right around here. Some of that is just because by virtue of having water here. But we've also been talking about the low pressure bias and the Modoki La Nina pattern with low pressure here and high pressure out over here. And we'll get into that in a bit in detail. But the short of it is this low pressure bias right here is feeding energy into the jet, consolidating it, making it stronger. We think that's only going to build as we get maybe 2 weeks out. That's where we were at Christmas when we had all that big surf and there was rainfall. That's kind of what I'm looking to the future, but you know, we'll get into that in a minute when we get into the MJO portion of the discussion and the La Nina portion. But for right now, you can see, even though, you know, the jet isn't roaring, there is something feeding it right here. And then you see the big split pattern over the U.S. West Coast, backdoor trough, and then it sort of does a mirror image of it over the Atlantic again. And just for the sake of completeness, I'll put this into motion. I mean, you're not going to see anything really different. You just see sort of the mirror image pattern in the Atlantic and the Pacific as you go out the next week. But nothing like, nothing raging particularly strong here. And of course, this time of year, southern hemijet weaker. The focus is all in the north. All right, but the jet stream does not make wind that gets traction on the ocean surface. It is just sort of like the fuel for the fire, so to speak, or the fuel for the machine that can generate surf. It is winds blowing on the ocean surface. So this is the model of surface pressure and surface winds. We see a couple of patches of 30, 35 knot winds, but very small in coverage. Really, the main one is up here, 40 knot winds in the Gulf of Alaska, and that's all fading out. Now, you see what really grabs your attention. We'll start here on Monday. Gale starts developing off Japan with 45 to 50 knot winds to 55 knot winds later Monday morning, 50 knots. Tuesday, pushing towards the international date line. That's certain, and up to 55 knots there for a little pocket on Tuesday morning. Still not at the date line. The date line's right here, 180 west. But we have 40, 45 knot winds on Wednesday evening, the 15th of January, over the date line, and that all sort of peters out. Some additional fetch tries to organize, but not nearly as strong. You get the sort of sense that it was all part of one big pattern, and that starts fading as we get into Friday and Saturday. Another thing to notice, high pressure here, 1036 millibars. In fact, let's just go back. I'm just going to go back a couple of days here just so you get 1024. I'm looking for the highest millibar high in here. 1020, that's not too high, but there is a 1040 that showed up somewhere in here. There's 1036, building high pressure Friday night into Saturday. There's your 1040 millibar high over the Great Basin. This is pretty typical, the generator of Santa Ana winds or Diablo winds, as they call it in Northern California. You have high pressure here, clockwise circulation. That wind pushes off the coast, and at least in the upper levels of the atmosphere. And then we're almost a week out. High pressure breaks down a little bit, but still the general pattern, supported by the jet stream pushing up and over, is high pressure over this region and an offshore flow. Pretty typical La Nina kind of pattern for California. So how do those winds affect the ocean? Of course, if they're strong enough, they generate seas. Right now, we do have a little bit of fetch up here in the northern Gulf of Alaska, producing, 40 knot winds, and that has resulted in 34-foot seas. but those are quickly to fade out. The focus is going to turn now on Monday to a point off Japan. New developing gale there, 36-foot seas building to 39 feet, building to 41 feet. This is on Tuesday morning, to 42 feet to 45 feet. That's actually an upgrade compared to even this morning when I was doing forecasts. So this would be Tuesday night, 45-foot seas west of the date line, then fading to 42 feet Wednesday morning, still 42 feet, 39 feet. As we get into Thursday morning, the gale passes over the date line, seas down to 3 feet, and then pretty much gone after that. We know there's some residual fetch up here, but you can see the main swell event right along this line here, plowing into Hawaii. It'll be Friday night and probably California 2 days later. We get into Saturday. We're looking for anything greater than 30-foot seas. We don't see it, nor is it really expected. Now here, this is a little bit better than what we saw. This is 180 hours out, wouldn't believe it, but 32-foot seas in the, we'll call it the North Dateline region. Maybe some swell to result from that. Going to the southern hemi, South Pacific Ocean, we'll just plow through this real quick. Looking for anything where seas are 30 feet or greater, not expecting to see it. There we are, 180 hours out, and no swell-producing fetch is expected. Then over to the North Atlantic. Yes, we have our gale off the U.S. northeast coast, lifting off to the northeast, but doing, if anything, it's really interesting. It's just storm after storm that pushes off the coast, but rather than make a track towards Europe, they all sort of get shunted off to the north, like the jet is setting up a big ridge over Europe. And that's really interesting because Europe was just getting pounded and there was early season snow and all that. Now it doesn't seem like it so much anymore. We're into Thursday, Friday. Now there is a decent gale with 39-foot seas approaching both Portugal, Spain, up into United Kingdom and Ireland. That fades out. Then there is a little, and another one as we get into Sunday. Also notice here, let's see if we can do this. Yes, there is supposed to be some sort of a front with south winds setting up, maybe making some south wind swell for Cape Hatteras up into Long Island and that area, but that's almost a week out. Notice, interesting, 26-foot seas falling southeast towards Morocco. So something to keep our eye on there, but that's a week out too. The South Atlantic will run through this. A little bit of a gale trying to squeeze through ice and land, and with 40-foot seas, actually not looking too bad in terms of coverage. 37 was at 39-foot seas. South Africa here, maybe some long-distance swell could result. Yep, and even remnants of the gale pushing to the northeast. So some hope there. We're into Friday now. After that, I think things pretty much settle down. A little tiny system pushes south of Africa as we get 180 hours out, but that's too early to be believable. And then the Indian Ocean, we'll put this into motion. Now here is a solid gale, a little bit, again, obscured by land. We see, in fact, let's go back. You can probably see this. Whoops, there we go, right there. Swell front pushing towards Australia and Bali and Indonesia. That shows up probably on Monday for Australia and probably sometime Tuesday for Bali and Indonesia. And some sort of a system behind that, maybe making yet more swell. This is like Tuesday, Wednesday, pushing north. You see the swell front from that. So we get into Thursday night and Friday. And then working its way up here into the islands there, the island chain. And then after that, things settle down. But Indian Ocean being fairly productive for the time of year. Local wind forecast for California right here, Hawaii out here, Southern California down here. Now this is probably too coarse of a grain to really be able to tell what's going on specific to select spots in Southern California, especially in regards to fire management, but maybe we have a model we can pop up. It doesn't go out as far as this, but we'll do that in a second. Anyway, you see high pressure, 1038 millibars. This is Sunday off of, I'll call it the Pacific Northwest, starting to generate north winds at 30 knots and wind swell pushing down into California. We saw that on the buoys. Trades, 15 knots for the Hawaiian Islands. Monday, more of the same, 25, 30 knot winds off of North California. Winds not too bad for Central California and Southern California. Trades, 15 knots for the Hawaiian Islands. On Tuesday, the pressure gradient breaks down, a light wind regime along the California coast, but offshore from, we'll say, San Francisco southward, nothing too hard indicated. Trades, light for the Hawaiian Islands. Wednesday, same sort of pattern, light wind regime for California, light trades for the Hawaiian Islands. Thursday, again, a light wind regime, light trades for the Hawaiian Islands. Friday, here we go, another bout of high pressure, a little gradient trying to set up off Cape Mendocino, 30 knot north winds generating some wind swell and northwest winds sweeping down the coast. Some sort of a cutoff low setting up north of Hawaii, generating north winds for the islands, but that quickly lifting off to the north. High pressure in control. The storm track coming this way, hitting high pressure, everything getting shunted to the north. Trades, kind of almost northeast winds, 10 knots for the Hawaiian Islands. Winds not horrible for California, but not great. And then into Sunday, basically the same sort of pattern. Wind forecast for Southern California, high-res model. This is in 3-hour increments. We have a version of it that goes in 1-hour increments. You can dig around on stormsurf.com in the weather model section of the site. In fact, let's see if we can show you at least how to get there. Up here at the top, models, weather. You go under there, you pick around, and you'll see there's a bunch of high-res models for a bunch of places in the planet. We're doing the 3-hour one here because it goes out 84 hours. This showing that offshore flow, not focused up in Santa Monica, more down towards Huntington Beach and that area. This was as of 5 p.m. Sunday. If anything, that builds Sunday night and then starts building for the entire area. Again, focused more down in the south part of Southern California rather than not northern part. And then Monday, then it just starts really ripping over Point Doom. And in that area, what is that? It says 20 knots, but this does not really take into effect the canyons and all that stuff. So I'm not even going to try to venture a guess, but you see a pretty strong wind event Monday afternoon in the north area down the whole way down into Dana Point. So take that under advisement. That continues into Tuesday. Oh, there you go. That is 24 to 26 mile per hour winds and probably a lot more if it's downsloping coming off of mountains there. You know your local topography better than I do, but that could make for strong offshore winds. That continues into Tuesday, Wednesday still. And let's see, we're about to run out of model space there. It looks like finally by Wednesday afternoon, the pattern starts breaking up. So the next really Monday, Tuesday are going to be kind of a little bit tense, I would think. Precipitation. So here is North California, Central California, Southern California. There's your blocking high pressure system, 1036 millibars set up off the Pacific Northwest. We're really focusing on rain and or snow. You see whatever precipitation there is, it makes it to about Vancouver Island. That's not even in the U.S. It's British Columbia. Another little bout there on Wednesday, maybe down into Washington, and that's about it as we get into later Thursday. High and dry. You do see bits and pieces of clouds, but typically that doesn't mean anything, and we're out to Saturday already. I mean, none of this is a big surprise. You just have solid blocking high pressure over the area. Now, here is the one little thing I saw. As you get into Sunday, you see this cloudy pattern, maybe some sort of a backdoor front trying to at least raise humidity here and even a drop or two out of the sky would be better than bone dry, but then that's pretty much gone. So that's sometime on Sunday. That's a week out. Again, I don't believe it. And again, the dividing line all seems to be well to the north. Precipitation anomalies basically right now, compared to the typical October-December timeframe. This is for October through December 24, compared to the 30-year average from 1991 to 2020. Greens, wetter than normal. There's that dividing line. We showed a chart similar to this just for California last week's video, and you can see just the preponderance of wetness all focused up here, very typical of La Nina, and how bone dry it is here and the whole way across the southern tier states. I mean, this is pretty much what NOAA forecasted. This is what the models said. This is consistent with a typical La Nina kind of pattern, and as of right now, that's what appears to be going on. Snow forecast for the Sierra. This is focused on Palisades, Tahoe, but you see literally nothing on the chart for the next 10 days. No big surprise. We're not even going to look at any other resorts because they're all basically saying the same thing. And then the temperature or the freeze forecast. Reds and grays are all above 32 degrees. This is the base of Palisades, Tahoe at 6,200 feet. This is the summit up at 9,000 feet. You see temperatures, at least today and into early tomorrow morning, are supposed to be cold enough, good for snowmaking if there were any precipitation, but then it gets warm and is above freezing from the summit and upwards the whole way into about the morning of the 16th. Then still pretty high snow levels, probably not even good for snowmaking. Till you get into January 18th, temperatures dip down for a day or so, then go up. I mean, for this time of year, this is very warm. Now, is it unusually warm? Is it something way out of the norm? No, but this smells very, very much like a typical La Nina and paired up with the inactive phase of the MJO kind of pattern. You know, it was wet up until when? Right about the New Year's, and now we're 12 days in and it's bone dry. I mean, it's been dry down in Southern California, but up in Tahoe in that region, there was plenty of snow. Things were going great. 12 days into it, this is not that big of a deal for Tahoe. If it weren't for the rains in Southern California, it probably wouldn't be that big of a deal for anyone. For the fires in Southern California. So, we'll see. We're going to get into the deep dive here in a minute. But before we do that, the surf forecast. All right, Sunday into Monday. We already know there's swell heading up there. Surf heights 12 feet, pretty much peaking right before sunrise, working their way down. Another swell showing up on Tuesday. Surf heights in the 12-foot range, working their way down. Then things just kind of bump along. Still 7-foot surf. Nonstop, and then perhaps another swell as we get into next weekend in the 9-foot range. Winds, you see it here, kind of not bad at all until you get into Thursday, then blowing northwest hard, and then things lighten up after that. Swell height 7 feet at 16 seconds for the first swell, 7 feet at 16 seconds for the Tuesday swell, and then a little bump of something else, I'll call it wind swell, but 6 feet at 13 seconds kind of thing. And then another little bump in the 4 to 5 feet at 19 seconds as we get into next weekend. Same sort of pattern for Northern California, focused on Ocean Beach in general. 8-foot surf Monday, fading into Tuesday. Another bump on Wednesday in about the 8-foot range. And another little bump on Sunday in the 8-foot range. Winds, you can see for yourself. Swell sizes, what do we got? 8. This is all showing wind swell on Monday. There we go. It finally picks it up. 3.5 feet at 15 seconds. I think it's going to be bigger than that just based on the buoys. Tuesday, 5 feet at 15 seconds sort of thing. And then another little pulse out here at 4.5 feet at 17 seconds, or 2 feet at 20 seconds, depending on where in the swell profile you look. San Diego, much smaller swell pattern, just due to the fact that most of the swell is going to be shadowed by the Channel Islands. Surf heights in the 1 to 2 foot range. pushing to 2.5 feet as we get into Wednesday, Thursday with the next swell, and then building to maybe 3 feet again on Sunday. Swell sizes, well, we're fading out in 13 seconds. Another little pulse, here we go. 1 to 1.5 feet at 17 seconds sort of thing. And then another one out here at 1.5 feet at 20 seconds. Even the north shore of Oahu, not particularly big. I mean, this is because most of this, I think, is pushing north of the islands. So what do we have? 4-foot surf, 4-foot surf, fading down 3 feet. There is some bigger swell that is supposed to be showing up out here, theoretically. Don't know if it's on. Okay, 2.5 feet at 15 seconds on Monday. Okay, fading into Tuesday. Another little pulse on Thursday at, well, that's just wind swells, all it's showing. And then another swell out here, 2.5 feet at 16 seconds. So no big surf forecast. Then we go over to Bali because there is swell pushing north in the Indian Ocean. Surf heights 11 feet as we get into late Wednesday and Thursday, and even bigger as we get into Sunday. Let's go look at swell heights. 6.9 feet at 16 seconds. I'll take that any day of the week. Slowly fading out, taking multiple days, and then bumping up again 7.4 feet at 16 to 17 seconds. Not a bad pattern. As promised, let's go take a look long-term at our two major weather oscillations that affect surf production and rain production long-term. MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We're going to start by talking about the MJO, the Madden-Julian Oscillation. There are two phases to it. The active phase, that's our friend. That's the one that's responsible for producing storms out in the open Pacific that produce surf. And then as the active phase of the MJO moves south of California, it also drags the jet stream theoretically further south, and that helps bring rain, much needed rain, into California and snow up in the mountains. They're the two phases of the MJO, active phase on one side of the planet, inactive phase on the other. They rotate west to east around the planet. It is when the active phase pushes over the West Pacific that things start getting interesting. It takes about 4 to 5 weeks for the active phase to make its way across the Pacific. The active phase is effectively a low-pressure system. That low-pressure system takes warm, moist air at the ocean's surface, starts sucking it up like a chimney aloft in the atmosphere. That gets tapped by the jet stream. The jet stream gets energized by that energy, a stronger jet stream, and it consolidates it, makes it more robust, and then that digs out troughs, and that makes storm, and that does all the good stuff we want. The inactive phase of the MJO, exact opposite. It's like a high-pressure system. It puts a cap on that chimney, does not allow warm, moist air to go up into the jet stream. The jet stream gets weak, and it splits. All right, so we're looking for signs of the active phase of the MJO. Another good key to know about. Active phase of the MJO, because it is like a low-pressure system, it reduces trade winds or dampens trade winds. Trade winds are generated by semi-permanent high-pressure systems north and south of the equator. The active phase of the MJO, though, is like a low-pressure system. It cuts into the high pressure and dampens it and weakens it. So we can monitor trade winds to kind of get a sense of what's going on. And that's what we're doing here in this chart. This is the East Pacific here. This is the West Pacific here. This is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but they have wind sensors on them. You can just look at the arrows. This is the 5-day average wind speed. So you can see in the East Pacific here, trades are, they're blowing pretty good, but nothing exceptional. A little bit stronger over the Central Pacific. There's the date line right there. And then that's New Guinea right there. And in the far West Pacific, trades pretty strong over here. But it is not the actual wind speeds that matter. It is the anomalies, difference from normal for this time of year. And lo and behold, what do we have here? We have westerly anomalies in the East Pacific. So trades not only are weaker than normal, they're literally the equivalent of blowing reverse direction. That's a good sign of perhaps the active phase of the MJO here. Over the Central Pacific, trade's dead neutral. And even in the far West Pacific, they're a little bit stronger than normal, but not too bad. So perhaps some sort of active phase of the MJO is in control of the Pacific. You wouldn't know it, though, by looking at everything that's going on. I mean, typically with the active phase, you'd be expecting rain. You'd be expecting the jet to be pushing the whole way across the Pacific. But I think what our real issue here is we have a Madoki La Nina setup, and that's just effectively overriding whatever influence the MJO might have. We'll get into that in a second. Let's go look at the trade wind forecast for the next 2 weeks. 850 millibar zonal wind anomalies. That is the east-west component of the wind. The blues and purples are stronger than normal trade winds, easterly anomalies. The reds and yellows, westerly anomalies, stronger than normal or weaker than normal trade winds. Okay, so this would be like the inactive phase of the MJO. This would be the active phase of the MJO. But get down here, there we go. This is for the whole planet. So the date line runs right up the middle here. Far west Pacific starts at 125 east, so right here. Okay, and the important area is the West Pacific. I call it the Kelvin wave generation area. During El Nino, when you have westerly anomalies over the date line, you get Kelvin waves, and that's good for feeding El Nino, but we're nowhere near that. It goes from about 125 east to just a little bit over the date line, 170 west. All right, in the U.S. West Coast, like California, is at 120 west. So this is past performance here. So you can see, now back in December, remember, the jet was raging. We had that massive surf. We were getting rain, at least into Northern California. Notice westerly anomalies were strong over the maritime continent here till about December 26th, something like that. The thought being the jet stream comes blowing over the maritime continent, hits these westerly anomalies, gets supercharged, and even though there's easterly anomalies here, up at the jet stream level, that's up 30,000 feet. This is down at like 4,000 feet. The jet stream gets supercharged so it can make good headway and consolidates, pushing across the Pacific, and even gets into Northern California, let's say. Okay, but then after about Christmas, notice these westerly anomalies got weaker. Okay, now also notice easterly anomalies got weaker too. It's like the active phase of the MJO that was here was pushing its way across the Pacific. And then here we go today. Easterly anomalies forecast really building strong over the date line. This does not look great on its surface for California in terms of surf production or rainfall or any of that. But if this same theory holds true, that it was really what was going on over the maritime continent fueling the jet stream, when you look down here, well, all of 5 days from now, that pattern is only forecast to be building and even stronger than what happened in December. And this, I think, I'm hoping, is the silver lining for our jet stream and precipitation into California. Again, this is pretty typical. I mean, look at this. We'll say December 25th till not even January 25th, 3.5 weeks. That's pretty typical of the MJO and its sort of periodicity. So I'm thinking, yeah, things are dry. The surf is dying off. Yeah, but you know what? It's probably just all MJO related, even though we have these strong easterly anomalies. Let's go dig a little deeper. Outgoing long wave radiation for the North Pacific. So South America, Central America, New Guinea there, Australia, the equator right there. Actually, this is the Equatorial Pacific, not the North Pacific. The equator right there, date line right there. The blues, wetter than normal skies. The oranges and reds, drier than normal skies. One could say active phase of the MJO and inactive phase. And remember when we looked over the East Pacific, trades were weaker than normal, kind of consistent with what's going on there. And then over in the West Pacific, we had easterly anomalies building. And now this is from a statistic model. Notice 5 days from now, that same pattern, all shifting east. And then 10 day or a week from now, or 10 days from now, 15 days from now, strong inactive phase over the West Pacific. Notice the building wet anomalies over the maritime continent. Strong active phase. That is 2 weeks from now. Theoretically, if the jet stream is coming right over here, that is the fuel to really fuel the jet stream to help it penetrate further across the Pacific. Now, this is the statistic model. This is the dynamic model, basically showing the exact same thing. In fact, if I can, there's the last frame of the model for the statistic model, last frame for the dynamic model. They look exactly in sync. Here is phase diagrams for those same two models. Statistic model over here, dynamic model over, where is my mouse? There we go, over there. Okay, now how do you read the chart? Well, the active phase of the MJO, this is plotting only the active phase of the MJO. Active phase moves from the Indian Ocean over the maritime continent, that'd be like Bali, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. And it just kind of, basically that pattern just continues indefinitely. The heavy dot is where the active phase is right now, so it's over Africa. That makes about sense. The further the dot is from the circle, the stronger it is. So, say modest in strength. Now, the statistic model has it moving somewhere to the central Indian Ocean, 1, 2, 3 different members. Two of them saying, oh, and if you're the closer to this circle or if you're inside the circle, incredibly weak. The further from the circle, the stronger you are. So two members say dead weak. Another member says pretty strong, if not strong. Not in the West Pacific where we really want it, but even over the maritime continent would be good. So moving towards the maritime continent 2 weeks from now, the dynamic model has it almost over the maritime continent, but weakening some. So a little bit of a difference, but not too bad. All right, so let's go out a month. This is the CFS model. This is a dynamic model, 850 millibar zonal wind anomalies, the blues, easterly anomalies, inactive phase, the orange and reds, westerly anomalies. But we have the MJO actually indicated on this, so we don't have to guess, the solid contour. Back in time, here's October active phase. Notice the westerly anomalies around it. Easterly anomalies in the inactive phase in November. In December, notice right here, and right around Thanksgiving, that's when all the action really started happening in the Pacific. Strong westerly anomalies over the maritime continent associated with the active phase of the MJO, pumping energy into the jet stream. And yes, there were strong easterly anomalies over the dateline, but the momentum from this was enough to get the jet stream pushing. Well, California's at 120, so the whole way across the Pacific and at least into Northern California. Now, here is the actual active phase of the MJO is pushing over the dateline region right now. It's got about another 3 or 4 days to go, and then it's done. Then moving south of California. Typically, I'd say somewhere right in here is when you'd really expect the big rainfall into California, but we know that's not coming. We know that the active phase itself is going to offer no help. It's when the active phase is over the maritime continent. That's at least last time when we got our big push. Now notice, inactive phase setting up over the West Pacific as we speak. Strong westerly anomalies. The last model only went out 2 weeks. But also notice, here is your building active phase of the MJO, maybe the last week of January into the first week of February or so. And I would guess if there's another target for rainfall and for storm production and surf production, this would be it. So I'm saying we got maybe a week and a half, 2 weeks, and then somewhere just beyond, I don't know, the 25th of January or so, I'm beginning to think the jet stream might come alive and the storm track might come alive, and the beginnings of hope for rainfall into California might start to reappear. And then here's the CFS model going out 3 months. If I don't believe a model a week, why would I believe a model going through months? Well, the CFS model has done a fairly reasonable job. All right, so, but past performance down here, this is the forecast on top, dateline right up the middle here, okay? Far West Pacific starts 125 east. So here is our last push in December of west anomalies that fed the jet stream. And notice we had strong easterly anomalies in control. Here is our forecast going out a week, strong easterly anomalies, no real westerly anomalies, but by, January 20th or so, the whole way into February 20th, if not beyond that, solid, not incredibly strong, but solid westerly anomalies forecast over the maritime continent. Also notice as you get into March here, the beginnings of March, the easterly anomalies theoretically dissipate. I'm not going to take any of this to the bank, and westerly anomalies push across the Pacific. If this happens, this would be a definite window for the Jetstream to go do its magic. And all this sort of smells of, well, our winter is stalled in January, but it's going to be a late winter. It's going to be tail or end loaded from February, March, and probably April. Maybe. Let's overlay the MJO, see if we can make any sense of this. Okay, there's our active phase. It's fading out. It doesn't even matter. With perpetual easterly anomalies, that's fueled by La Nina. We're going to get into that in a second. Here's the next coming inactive phase of the MJO now through about January 30th, something like that. And here comes the active phase, fueling the west anomalies, low pressure bias, and theoretically wiping out easterly anomalies on the date line, opening the storm door. Now, why is all this going on? Let's overlay the low pass filter. This is a high pressure, low pressure bias. So the solid black contour here is, see, I'll turn it on and off just so you can see what's going on here. This is over the maritime continent. This is the low pressure bias. This is the classic sort of Madoki La Nina pattern. Low pressure bias over the maritime continent, and the dotted contour, high pressure right over the date line with 1, 2 contours, a third contour forecast in January. This is incredibly late for La Nina to like be waking up in January. Normally it does all this stuff. It peaks out like what is here in February. Normally it peaks out in like Thanksgiving, between Thanksgiving and Christmas. So a very late breaking La Nina, but we'll see. This is not as much of a La Nina as one would want to believe. Notice the easterly anomalies fading out. I mean, some of this is just change in seasons. It'll just kill it anyway. So here's what we have to look forward to. I am pinning my hopes on the westerly anomalies late January all the way through month of February, feeding the jet stream just like it has been, just like it did in December, and hopefully offering some storm incursion into California. We're going to pick up the pace here a little bit. Subsurface temperature anomalies. This is an animation. At some point, it'll quit flipping around, but you get the general idea. This is the West Pacific here, East Pacific here. There are buoys with anchors strung down, with anchor lines strung down here, sensors on the anchor lines. They collect subsurface temperature data down 100, 150, 200 meters in the ocean surface. The short of it is you can see colder than normal water in the East Pacific, a building pool of warm water in the West Pacific, that all driven by easterly anomalies in the La Nina pattern, basically creating upwelling in the east and taking all the warm water that's normally here, building it up in the west. The good news is that warm water is building in the West Pacific and not being pushed the whole way into the Indian Ocean by virtue of the fact that the low pressure bias is like right on the border, trying to edge into the Pacific, producing westerly anomalies, taking warm water that's in the maritime continent, pushing it into the Pacific. So it's all just pooled right here. All we need is trades to die, and a lot of this will start sloshing off to the east. Pentad sea level anomalies here. America, Central America, Ecuador, Peru, Chile down here, Australia there. This is the equator. This is the date line. These are not temperatures, though they sort of relate to temperatures. The height of the ocean surface. If the ocean is higher than normal, one assumes there's warm water at depth that displaces water above it. If you have cold water at depth, it contracts, creates a divot on the ocean surface. So on the equator here, there's the Galapagos. You see them down minus 5, 10, 15 centimeters below normal. And it's only 5 degrees north and south of the equator that really matter in terms of driving this whole ENSO machine and the jet stream and all that. But we have 15 to almost 20 centimeter below normal anomalies, but isolated here in the Central Pacific, not in the east, certainly not in the west. In fact, look at the positive anomalies here suggesting warm water at depth. So just sort of a confirmation of what we were looking at before. The one-year trend, East Pacific here, West Pacific here, are El Nino fading out in January of last year. Then 1, 2, 3, 4, 5, and now 6 pulses of cold water building. Notice they are not up against the coast of Ecuador. They're all out here south. Hawaii is at 158, so basically south of Hawaii. Latest one, almost the biggest, I'd say, but also westward displaced. Here's your building pool of warm water, pretty typical of a Modoki La Nina. Sea surface temperature anomalies reflect the same pattern. South America, Central America, Australia, New Zealand, equator right there, dateline right there, there's Hawaii right there. Here's our cool pool. It is not a big cool pool. If it were a real El Nino, a real La Nina, it would all be right here. Instead, it's out here at the dateline. In fact, there's warm water in the East Pacific, warm water in the West Pacific. So this is what they call a Modoki La Nina, a sort of a La Nina, but not really. Typically on something like this, I would expect the jet stream, wherever you have cold water, you have less evaporation, higher pressure, so I'd expect the jet stream to go kind of up like this and down like that. Unfortunately, even if we're doing the backdoor thing, we'd be getting plenty of precipitation into California, but we're not even getting that at the moment. Again, I think a lot of that is just due to the lack of energy right here for the moment. The low pressure bias is kind of tapped out because the active phase of the MJO is somewhere over in here. But within the next 2 to 3 weeks, I think things are going to wake up and we'll be back in business. Sea surface temperature anomaly trend for the past 7 days. Well, sort of a generalized warming pattern in the east, but things not really getting any colder. If anything, I'd say we've stabilized, or if anything, our La Nina is probably peaked out by now, and then a stable pattern in the west. The sea surface temperature index for this is in the Nino 1.2 region, so just right there along Ecuador and the Galapagos Islands, pretty much holding steady. Today's value, 526 thousandths of a degree below normal, so pretty much neutral, between half a degree above and half a degree below. That's considered neutral. It's once you get it below half a degree, and you can see temperatures were actually colder back in October and November. Now we're steady, but this is not the official El Nino monitoring region. This is right here. Our temperatures bottomed out at nearly 1.5 degrees back right around at Christmas. Today, we're slowly rising 1.201 degrees below normal. This is focused right over the center of the heart of our Modoki La Nina. Again, half a degree below and above is considered neutral. Half a degree to 1 degree is considered a weak La Nina. Half a degree to 1.5 degrees is a moderate La Nina, but you got to be in that pattern for effectively 5 months, and we've only been in the moderate category for not even 4, but right about 4 weeks, let's say maybe 1 month. So, and we're not going any deeper, and just given the time of year, historically, I don't think we're going to go any deeper. Sea surface temperature, corrected sea surface temperatures for the week of January 1st. This is the official Nino 3.4 region. We actually rebounded from minus 1.1 degrees to minus 0.7. And according to this, you got to be below half a degree for, 5 months? We've been below half a degree for about a month. So not too bad. So what does the atmosphere think is going on? Well, I think we pretty much know from looking at all the charts, but anyway, looking at hard data always helps. The difference in pressure between Darwin, Australia, and Tahiti. When pressure is lower in the Pacific, that's probably a good sign that the active phase of the MJO is going on, and the index goes negative. Hey, lo and behold, minus 20.82. And we've been pretty much negative for, you go back about 13 days. Pretty consistent with the active phase of the MJO moving over the Pacific. The 30-day average, actually, let's go look at the contribution. So you see, we were quite positive there back in December. Inactive phase of the MJO when we were getting all our weather and everything. So we'll see. 30-day average, 2.11, basically neutral. We were up at, where are we up at? Wow, 14.3 in the 20th of December. So definitely heading down. This is a good indicator for the active-inactive phase of the MJO. The 90-day average, 5.79, where were we? 5.83. If you're up at 8 to 10, then you're in La Nina. This suggests we're not even in La Nina. Let's go look at a graph real quick. From an El Nino, La Nina perspective, this really tells the picture. Neutral is, in the white category. Downward pushes are the active phase of the MJO. Upward pushes the inactive phase. There was our inactive phase. Now we're fading out, going into the active phase. No clear trend. If you draw a trend line through this, pretty much hovering right around neutral. So this doesn't even suggest strongly La Nina. So what is the forecast? All right, this is great because just like a day or two ago, the actuals for the month of January posted. This is the forecast for sea surface temperatures in the Nino 3.4 region, PDF corrected from the CFS model. The forecast for January was down at exactly 1 degree below normal. And then instantly, and this has been happening for the past 3 or 4 months, the corrected data or the actual data comes in, the model goes, well, I certainly blew that. I was forecasting for the temperatures to be way colder. Then it goes, boom, I'll just shift it off for 1 month, Well, that ain't going to happen. I'd say we're probably at our peak right now. This shows what? Minus 0.7 of a degree. Maybe we'll dip a little bit more. And then after that, it's a slow upward trend. And then we'll put this all in context. Subsurface temperature forecast. So this is actuals from November, December, and January. The Pacific Basin starts here at about 120 east, and then Ecuador is about 80 west. So this is for the whole planet. You see warm in the west, cool in the east. That built as we got into January. But then for February, the cool pool fading, February, March, all but gone by mid-March and April. And notice this, building warming in May, June, July, August, September. Notice it's not building over here in the east, but it's not going cold, suggesting a 1 year, 1 winter La Nina pattern, and that's it. And I know this is a bit small, but here is the same thing for sea surface temperatures. South America, United States, Australia, equator right there, date line right there. This is for February. There's our cool pool. This is even represented larger here than what it is on actuals. And this is the forecast from the CFS model. So cool pool starting to fade in March, all but gone in April. Then some lingering cool water out here in May, June, and then almost gone in July. And then the all-important precipitation forecast. And this on its surface doesn't look good. It's consistent with what kind of has been already happening. We saw the actuals very wet in the Pacific Northwest and over into the Rockies of the Northwest. Bone dry on a line going from Cape Mendocino over to the tip of Texas down into almost Cape Hatteras. That is for February. Same pattern, just a little bit more moderate in March. Same pattern in April, and then May, June, and July, it all just kind of breaks up. So this in and of itself relative to Southern California, that's not going to tell you a whole lot. I mean, whatever precip Southern California is going to get, it's going to be a sudden burst sort of type event. And really, this holds true for even Northern California from San Francisco southward. The model suggests very dry in San Francisco. We'll see. I was thinking 85% of normal precip for here up into Tahoe. This doesn't really show that. I guess we'll just have to see. So for right now, we are in the lull, hopefully, between active events. We had a big one there in December. Looking at all the data, I mean, you kind of make up your mind too and let me know what you think. But what I'm seeing is the Jetstream is fueling everything, and that fuel is coming from the low pressure bias integrating with the active phase of the MJO over the maritime continent. That whole pattern is supposed to refire up here again as we get, let's say, the last week of January, but certainly the whole way through the month of February. If there were ever a time for another burst of big wave or even swell-producing events, that's when it would be, I would say, the month of February. And if there's ever a hope for precipitation into the southern parts of California, that's when I would say it would be. Clearly, the next 2 weeks, there just literally is nothing forecast, even up into Oregon in that area, which has just been getting pounded and been so wet. The high pressure set up over the Great Basin, just locking everything down. But I think once the Jetstream wakes up again in February, we will be back in business, hopefully, and hopefully some of that reaching down into Southern California. Till that point in time, we just have to hope that the Great Basin high doesn't get too strong and make too much more of offshore winds, though we see that there is an event forecast for Monday and Tuesday as well. So just keep that in mind. Beyond the La Nina pattern that we're currently experiencing is forecast to be a rather short-lived event. And as we get into the summer, it's all supposed to be over. What will we get after that? Will we go to El Nino? Probably not. Will we go back to La Nina? Hopefully not. Maybe neutral would be a good thing for a change. I'll take it because it's been certainly just whipping back and forth from one to the other, El Nino to La Nina to El Nino, and a little bit of just equilibrium in the atmosphere might be a good thing. All right, that's it for this week. If you enjoyed the video, give us a thumbs up. If you have a comment or question, write it up down below. If you haven't subscribed, click the Stormsurf icon in the lower right-hand corner of your screen. Get yourself signed up. Get automatic notifications when the videos are posted. And of course, if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, we are done for this week. We'll do it again next week, same time, same channel. Stay safe, stay vigilant, and keep dialed into your local authorities, especially for the folks in Southern California. We are thinking of you. All right, that's it for this week. Good night.